Look at it. Does anybody have any questions? Number 7. Miss Didi, can I write down these things as you're going over them? Yes. Yes, you should. Okay, number 7. So below are the verbal, numerical, and area representations of expressions. Remember, this whole chapter is over algebraic expressions. Use what is given to fill in the rest of the table. Okay? So for the first row of this table, it says add twice a number to 3, then multiply the sum by 5. Let me read that again. Add twice a number to 3, then multiply the sum by 5. So what would that be as a numerical representation? First of all, does everybody have one of these review sheets? Just want to make sure. Put the phones away, please. Oh, I was like, what are you doing? Yeah.
Is it like x squared plus 3 parentheses 5?
Like this?
Nah, like parentheses around the equation.
Oh. Okay, there's no equation there. Equation has an equal sign, but I know what you mean. Like this? You want the 5 after or before? Before. Okay. All right, so we have an expression. Do you agree with that expression or not? There's a lot of good things in there, but there's one small thing that's not quite right. What's not quite right here? Yeah. When you say twice a number. So how old are you? 17. So if I say twice your age, is that going to be 17 squared? Or is that going to be 2 times 17? Yeah. So we don't want x squared. We want 2x. I said add twice a number to 3. So like this. And then multiply that sum by 5. So that is the correct answer. But hey, he gave an answer, and that's important. You know, he raised his hand. You've got to be open. You have to participate in this class to know what you're doing. Now, what if I had this? 2x plus 3 times 5. Is that the same? No, it says multiply the sum by 5. So that's why I had to put 2x plus 3 in parentheses and then multiply the whole thing by 5. Any questions about that? All right, so my area model, I'm looking at, in this case, a rectangle. Okay, what is the width of my rectangle over here? What's the width? 5, yes. So this is 5. 1, 2, 3, 4, 5. And you don't have to exactly do it like this. On the top, what do I have? My length. And the length is 2x plus 3. Now, how long is x? We don't know. We just have to show 2 lengths of it. So maybe that's x. There's 2x. Okay? So I bring this down like this. And then 3. Well, if that's 5, 3 has to be a little bit shorter than that. And that also comes down here. Okay? What am I going to show for this middle part? Right here. What is that area? 10x, yes, because it is 5 times 2x, which is 10x. And what is this other part over here? The other area in black? 15, yes, because this 5 is the same width over here, correct? So 5 times 3 is going to give me 15. Oh, that's a little too wide. 15. So your area model, you could also, since they don't have it there, you could also write 10x, let's do narrower here, 10x plus 15. So that is your area model. You have shown it is 5 times 2x plus 3, and you've also shown that it is that sum of areas. Questions on that one? So 15 plus 5n, a verbal representation. How could I get someone to write that expression of 15 plus 5n? What could you say?
5 times the number added to 10, 15.
Okay, 5 times a number added to 15. What do you guys think of that verbal representation? Is that correct? Yeah, it works. Is that the only way I could say that? No. I mean, there are going to be similar ways. You could say the sum of 15 and 5 times a number. Okay? The sum of 15 and 5 times a number, because when you multiply, you have to think about order of operations. But yes, that will work. Not the only way. Other ways to do it. So, and you can switch it around a little bit. I mean, you can say this is 15n or 5n plus 15 because that is the same. So in this case, I'm looking at a rectangle. This one is a little bit more complicated. You need to think of the reverse of the distributive property and think about factoring. What's the greatest common factor of both of those expressions? 5, yes. So you're going to divide by 5, sort of, and take that 5 out. And when you divide 5n by 5, you have what left? 1n plus 15 divided by 5 is 3. Okay? So as you are doing this, your width and your length is over here, your length is over here. What's going to be my width? 5. So this is 5. This is my length. What goes on top? N plus 3. So this is my width. This is my length. This is going to be n plus 3. We don't know the length of n. Okay, but I'm going to say that my 3 is a little bit long if that's my 5. So I'm going to take this back and, of course, erase that. We'll say this is 3. It's a little bit shorter. So what is the area of this part in blue? 5n. And what is the other area beside it? 15. And so there you have, it is 5n plus 15, or 15 plus 5n. That's your original. And you also have shown it as a rectangle. Okay? Questions on those two? This one is a little bit harder because you had to factor out that 5. Okay? All right. Let's go to the next one. This one is probably the most difficult type. Okay? Mohammed, can you have your head up? Put down, please. So we have the figure over here. Okay. Is it Jeremy? Jeremiah? What's your name? Nope, not Mark, beside you. Josh, I knew it was a J. I knew it was a J. Sorry. Can you put your hood down, please? Thank you. So looking at this figure, there is nothing there. Nothing there. If you have done some more of these, and I think there might have been one or two maybe on the homework if you happened to look at it yesterday, this to me almost looks like they could all be the same. Okay? So, knowing that, I'm going to say that this is half of this length right here. Your block? So I'm going to say this is a 1 over here, which means this length here would be what? If this is 1, and I said that looks like half of it, that would be 2. Now again, this is all kind of relative, but you're kind of looking and basing it on what you have observed before. Okay? This up here, what do you think that could be? Yeah, your variable. So it could be x and something like that. Now, I was trying to look at this a little bit earlier. And I was like, okay, what is this length to this? And I was like, is it exactly the same? It's pretty close, and there are a couple different ways you could do it. But I think it has to be a number, because if it was another x, if it was the same amount, then they wouldn't put it over there. They would have it in this column. So I don't think it's another x. I would just say if that's 1, if this is 1 length here, this looks to be about 1, 2, maybe 3. Like I said, this is the most difficult, but you kind of base it on what you have before. Notice this is not a full rectangle. Not a full rectangle. And that is huge to recognize. Okay? So as you look at this, what is the area of the first rectangle? 2x. Does everybody agree with that? It has a width of 2, a length of x, so that is 2x. So over here, we can say that's 2x. Now, looking at this area, what is that area? 3. Notice it has a different width than what we're used to looking at over here. So this, we said, was half of that. 1 times 3 is 3. That'd be 3 units squared. So this is going to be 2x plus 3. So now verbally, how would I come up with that expression? How could I get someone to write 2x plus 3? You could say, anyone?
2 times a number plus 3.
Yes. 2 times a number plus 3. Or you can say add 3 to 2 times some number. Again, there are many different ways to say the verbal expressions. And I am recording this, so I will get this up so you will be able to see it. Any questions on those first 3? All right, the last one, n plus 6, that quantity squared. N plus 6, quantity squared. So I'm going to have, what kind of a figure is that going to come up with here? Or do you want to do the wording first? I just kind of said it, didn't I? You could say, well, some number plus 6, comma, and the comma sometimes can be a big help. Then, or that squared. Or I should say, then take that squared. Something like that. That squared. Some number plus 6, that squared. Or then that squared. Or you can say square the sum of n, some number in 6. I mean, there's several ways. All right, but what is this going to look like? Okay. And I don't have to simplify. You're absolutely right. But what is this going to look like visually? And well, I guess we kind of do need that. So first of all, this is not n squared plus 6 squared or n squared plus 36. I cannot tell you how many of you do that. You are forgetting the middle term.
Is it like 2n plus?
It is not 2n.
It's not 2n?
No. What I suggest is actually writing it out and saying n times n times 6. So that is n squared plus 6n. And then you start from the second term of the first binomial and multiply that by each term in the second. So plus 6n plus 36, which gives you n squared plus 12n plus 36, which is what Caden said. Caden? Yeah. I have Caden, Zayden's, and I know it's something like that. But getting back to this, the n plus 6, that quantity squared, what is my picture going to look like? I will have 2 identical rectangles in there, yes. But when you square something, if I say 5 squared and say show that to me as an area, what shape is that? It is a square. Yeah, so this should be, the whole thing should be in the form of a square. What is my width? If I say n plus 6, that quantity squared, what is my width? N plus 6. So let's say here's n. What's going to be my length? N plus 6. I'm really trying to make this be a square. This is n plus 6. So let's say here I need n squared. Okay, this is an n. This is my 6 over here. What is this length right here? Or width? Yeah, that is n. If this is n, it's going to go over here. This is n also. And I'm going to have this down here. This one doesn't quite look the same. What is this amount right here? N. That is also n because it's n at the top. What is this right here? 6. And what is this over here? 6. So this is n squared. Here is 6 times n for 6n. Here's another 6 times n, which is 6n down in that position. And then 6 times 6 here is 36. So when you see this n plus 6 squared, you need to think of a square with 4 smaller areas where these two can be added together. And that's why when you multiply it out, it ends up being n squared plus 12n combined here plus 36. There's your head swimming. You're like, I don't even know. That was a great one to ask. Number 7. I think everybody gained by paying attention to that. So good suggestion there. Any questions on number 7? By the way, I will be here after school tomorrow for an hour if you just want to check in, and you don't have to tell me during the day or anything. I am always here, except next Thursday I won't be, but I will be this Thursday. All right, other questions on this review? Number 9. Ha, yes. So, number 9, what is that monstrosity? What do we call that? What is it? What do we call this right here? Besides a monstrosity. No, not a trinomial. It is an expression. I mean, that is what we're talking about for this chapter. Is it an algebraic expression? No, because there's no variable in it. But it says, which of the following expressions are equivalent to that? What do we have to do and follow in order to get a correct answer here? PEMDAS. PEMDAS. Yes. And when you hear PEMDAS, I hope you think of it kind of like this. Because it could be PEDMAS instead of PEMDAS, right? What does the P stand for? Parentheses. You do those first. And the E? Exponents. And what's this M/D? Do you always multiply before you divide? Do you always divide before you multiply? No, you have to do it in order from left to right. So multiplication and division. And A and S, addition, subtraction, right? Addition, subtraction. And that too is left to right. Okay, so now let me erase some of this. So as I look at this expression, there is a correct order. There should only be one answer. What would I do first here? According to PEMDAS, I should do what? What's inside the parentheses? Well, there's several parentheses. Well, you got to look at the innermost parentheses, and you're looking at 9 minus 2, which is 7. I strongly recommend only one mathematical operation per line, okay? So I've got 5 times 2 plus 7 times that 7 I just found times 3 minus 4 plus 1. All right, so here's my simplified version. Do I have any other parentheses where I can do an operation on the inside? No. So I'm pretty much done with the parentheses. Do I have any exponents? No. Then it says multiplication, division from left to right. So as I read, I got a 5 times 2. Should I take this 5 and distribute with everything? No. Okay, you got to do what's inside. Well, I guess these are parentheses. Inside the parentheses, right here. And then you do see, I've got some addition. No, then I've got 7 times 7 and 7 times 3. Which should I do first? Nope. Left to right means 7 times 7. So 7 times 7 is 49. Leave everything else the same to the right and everything else the same to the left. All right, so I'm still looking inside these parentheses. Left to right, and then what am I going to do? 49 times 3. I like making these little V's that kind of shows me this is what I'm doing next. 49 times 3 is the same as 50 times 3 minus 3, which is 147. guys ever multiply like that? It's okay, you can say no. All right, so I have 5 parentheses 2 plus 147 minus 4. What would you do next? Inside parentheses, am I going to add or subtract? Should add. 2 plus 147 is 149 minus 4 plus 1, 5 over here. Now I've got parentheses. 149 minus 4 is 145. Multiply or add? Multiply, and that is 725. Check my math. Plus 1 is 726. Now, which of the following expressions are equivalent to 726? Do you see anything equivalent? E. And we're done, right? Are we done? Is it getting hot in here, Demetrius? Oh. No, not necessarily. Which one? D. How do you know D? Well, it's the same one as we had right here, right? So yeah, that should be equivalent. What about 341? Nah, we know that one's not because we already have a single answer. What about F? 5 times 68 plus 1. We don't have that. Maybe I should try. What is 68 times 5 plus 1? 341. What is it with 341? You're like, no, can't be that one. What about C? Well, you're like, oh, 5 out front. Okay, 2. They got a 2. And then they got 63. Oh, geez, do I have to do this? 2 plus 63 gives you 65. 65 minus 14 gives you 51. 51 plus 21 is 72. Minus 4 is 68. So that is 5 times 68 plus 1. Wow, that's the same as this one. So that's a no. I think we have them all. Should we give up? I hope not, because you better check this last one. What would I do first in this letter A to see if it's equivalent? Do we have some parentheses? Yes. What is 2 minus 4? It is not 2. Negative 2. Is there really a difference? Yes, there is. Just think. If you had negative $2 million in the bank or $2 million in the bank. That's a big difference. All right, so put that there. We got the 5 on the outside. Plus 7 times. What's 9 minus 2? 7. Gosh, we got another 3. Another parentheses plus 1. I'm kind of going up, although I can't go up a lot. What would I do next? So I have 5 parentheses, negative 2 plus 7, parentheses 7, parentheses 3, parentheses plus 1. 7 times 7 would be 49. And I know in the next one I would multiply again. 49 times 3 is 147. I'm kind of going up and down here. Plus negative 2 times 5 and plus 1. Negative 2 plus 147 is 145. Times 5 plus 1. What is 145 times 5? Ooh, 725 plus 1, 726. Oh my gosh. That is the same. It is equivalent, is it not? So we have to circle that one also. So you might have to do some work to figure out some of these equivalent expressions. So A, D, and E are all equivalent to the first expression. Another good one. They're all good. All right, so that was the last page, right? Almost looks like we're working backwards. Any other questions? How about number 4? Use the figures below to answer the questions. So, a couple of things I want to give you as a hint. I'm going to ask you, what do you see? And as far as a shape of the figures that are here. So just take a look at it for just a couple of seconds, and I'm going to say, do you see this when you first look at it, or do you see this? So everybody look at that shape. Is it Jeremiah or Jermaine? Jermaine? Hey, Jermaine, I want you to do well, okay? So as you look at this shape, how many of you see a square minus some tiles? Anybody see squares minus some tiles? No? No one? Does anybody see a rectangle plus 2 tiles? Yeah, there are 2 totally different ways to answer this. Okay? So nobody saw the square. So we're looking at, I'm going to go first then. This is a rectangle plus a couple of tiles, right? The other thing I'm going to tell you that's really important on these problems is everything has to be related to the figure number. That's the only thing you have to look at. Are you hearing things again, Anthony? It's okay. All right, so for figure 1, as you look at this, what is the size of the rectangle that you see? 2 by 3. And then we also have what at the bottom? 2 1 by 1. So is it a 2 by 3? That's an area, right? That's an area. Plus these individuals. Okay, so you see a 2 by 3 plus 2. Okay, figure 2. What do you see for the rectangle? A 3 by 4 and 2. A 3 by 4 plus 2. What do you see in figure 3? I really am not trying to insult your intelligence, but what do you see? What size is a rectangle? 4 by 5 plus 2. Gosh darn it. 4 by 5 plus 2. So what do you notice? How does this relate to the figure number? What is the width? How does the width relate to the figure number? How does the width of your rectangle relate to your figure number? It's always one number higher, right? It's always one number higher. How does the length relate to the figure number? It's always 2 numbers higher. 2 numbers higher. And what else do we have to think about besides our rectangle? Those 2. And it's always been plus 2, right? So if I were to write an algebraic expression for this series for figure n, what would my width be? N plus 1, because the width is always 1 higher than the figure number, right? What would my length be? N plus 2. And that is the rectangle itself. And then what do I need to put with it? Plus 2. Now that is a lot to unwrap. Do you see how I did that? You have to ask yourself, what do I see? Do you see a rectangle plus 2 more? How does that rectangle relate to the figure number? Well, the width was always 1 more, then the figure number, and the length was always 2 more. Now, you could simplify this. I would take this answer, or if you simplify it, it would be n squared plus, and you do this, 2n plus n plus 2, and then plus 2. So you could rewrite it as n squared plus 3n plus 4. So I would take either one of these. So everybody see where I got those numbers? So then they say how many squares or how many tiles are in the 22nd figure? Well, that would be figure 22, right? So substitute 22 in for your n. And you have to go back to the expression. So this would be 22 plus 1 times 22 plus 2 plus 2. And this is 23 times 24 plus 2. I don't know what this is. Does anybody have 23 times 24? 5 what? 552 plus the 2 means there would be 554 tiles or squares. Okay? And we could have done it by thinking of it as a square. Some of you might see a full square and then minus, in that case, 1. For figure 2, minus that 2. Figure 3, the square minus 3. It would be a very similar way to do it, okay? So, all of these questions are very doable, but again, this is getting you to think in a different way and not do a bunch of problems like you've done in the past. This, because you're not used to thinking way, it is not going to be an easy test for several of you. And those of you that are not paying attention, it's going to be rough, okay? This is 100 points on this test, and it's 80%. All tests are 80%, okay? So please look at this tonight. Go through and try to do the remaining problems. Be ready and come in with more questions tomorrow. And if you're not sure, we could have a study session. If several of you want to come tomorrow night just to make sure you're understanding things, we can do that. If you feel pretty good, that's fine too. So make sure, again, you have all the homework 0, 1, 2, and 3 done by Friday at midnight, because that is the last day you can turn in homework. Okay? All right. Well, we have hit some of the more difficult ones. Number 5. A lot of people have problems with number 5. When it's true, false, it's like, I don't know. And then you have to justify also. Okay? So finish working on that.